Okay, so, well, let's start with an easy case where we should be able to know the answer to both sides. So let's look at a special case. Let's look at the case where curl F is 0. Then, well, we'd like to conclude that F is conservative. That's what we've said. Well, let's see what happens. So, Green's theorem says that if I have a closed curve, then the line integral of F is equal to the double integral of curl on the region inside. And if the curl is 0, then I will be integrating 0. I will get 0. Okay, so this is actually how you prove that if your vector field has curl 0, then it's conservative. Okay, so in particular, if you have a vector field that's defined everywhere in the plane, then you take any closed curve, well, you will get that the line integral will be 0. Strictly speaking, that will only work here if the curve goes counterclockwise. But otherwise, just look at the various loops that it makes and orient each of them counterclockwise and sum things together. So let me state that again. So, okay. So a consequence of Green's theorem is that if F is defined everywhere in the plane, and the curl of F is 0 everywhere, then F is conservative. And so this actually is the input we needed to justify our criterion. The test that we saw last time saying, well, to check if something is a gradient field, if it's conservative, we just have to compute the curl and check whether that's 0. Okay, so how do we prove that now carefully? Well, you just take a closed curve in the plane, you switch the orientation if needed so that it becomes counterclockwise, and then you look at the region inside, and then you know that the line integral will be equal to the double integral of curl, which is the double integral of 0. Therefore, that's 0. But see, okay, so now let's say that we try to do that for the vector field that was on your problem set, that was not defined at the origin. So if you've done the problem set and found the same answers that I did, then you will have found that this vector field had curl 0 everywhere, but still it wasn't conservative, because if you went around the unit circle, then you got a line integral that was 2 pi. Or if you compared the two halves, you got different answers for two paths that go from the same point to the same point. So, it fails this property. But that's because it's not defined everywhere. So what goes wrong with this argument? Well, if I take the vector field that was on the problem set, and if I do things say that I look at the unit circle. That's a closed curve. So I would like to use Green's theorem. Green's theorem would tell me the line integral along this loop is equal to the double integral of curl over this region here, the unit disk. And of course, the curl is 0. Well, except at the origin. At the origin, the vector field is not defined. You cannot take the derivatives, and the curl is not defined. And somehow that messes things up. You cannot apply Green's theorem to the vector field. So you cannot apply Green's theorem to the vector field on problem set 8, problem 2, when C encloses the origin. And so that's why this guy, even though it has curl 0, is not conservative. There's no contradiction. And somehow you have to imagine that, well, the curl here it's really not defined, but somehow it becomes infinite, so that when you do the double integral, you actually get 2 pi instead of 0. I mean, that doesn't make any sense, of course, but that's one way to think about it. Okay, any questions? Yes?
But since we know the work that we do, can we find the curl of f at that point?
Well, so actually it's not defined, see, because the curl is 0 everywhere else. So if the curl was well defined at the origin, you would try to then take the double integral. Well, no matter what value you put for a function, if you have a function that's 0 everywhere except at the origin and some other value at the origin, the integral is still 0. So it's worse than that. It's not only that you can't compute it, it's really that it's not defined. Okay. Anyway, that's, like a slightly pathological example. I mean, yes? Well, we wouldn't be able to, because the curl is not defined at the origin. So you can't actually integrate it. Okay, so that's the problem. I mean, if you try to integrate, we've said everywhere where it's defined, the curl is 0. So what you would be integrating would be 0.